Our bell ringer question today says, what is the measure of the missing angle? So we know that the three angles in a triangle should add up to 180 degrees. So we're going to do 180 minus 65 minus 25. Which leaves you with 90. So our missing angle here would be 90 degrees, which is also a right angle. So today we're going to work on classifying triangles. This addresses standard 7 GA2. We will look at classifying triangles based on their angles and on their sides. So on this first slide here, it says types of triangles based on angles. So we can have an acute triangle, which is where all three angles that are in the triangle are acute, or in other words, less than 90 degrees. We can also have a right triangle where exactly one angle is 90 degrees. And then we can have an obtuse triangle, which is where one angle is greater than 90 degrees. So notice with acute and obtuse, with acute, all three angles are acute, but with obtuse, we can't have three obtuse angles because an obtuse angle has to be greater than 90. So there's no way that we could have three of those and still have a triangle that the angles added up to 180 degrees, which is why we only have one obtuse angle in an obtuse triangle. Now we can also base it on the sides. So equilateral, kind of self-explanatory there. So each of the sides are equal. So all three sides equal is an equilateral triangle. Then we have an isosceles triangle, which has two equal sides. And then a scalene triangle has three different side lengths, so none of the sides are the same. Now, it's also important that you know if it has two equal sides, then it also has two equal angles. And if it has three different sides, then all three angles are different. And if it has three equal sides, then it also has three equal angles. So no equal sides on a scalene, no equal sides would mean no equal angles. Okay, so let's look at our first example. A triangle has angle measurements of 48, 48, and 84. What kind of triangle is it? Okay, so we can see that it has two angles that are the same. So remember, if it has two angles that are the same, it also has two sides that are the same. And you can refer back to that last slide. So if two sides are the same, that makes it an isosceles triangle. Okay, pause your video for just a second and solve example 2. So we have measurements of 60 degrees, 60 degrees, and 60 degrees. So if we have three angles that are the same, then we would also have three sides that are the same, which would make it equilateral. A triangle has side lengths of 5, 10, and 10. Is this triangle isosceles? It does have two sides that are the same, so yes, it would be an isosceles. Since those two sides are the same, it would also have two angles that would have the same measure. 91, 57, and 32. What kind of triangle is this? Okay, so acute would mean all three angles are acute, or all three angles are less than 90 degrees. We have this one here that's 91 degrees, so it cannot be acute. A right triangle says that we would have one 90-degree angle. We do not have a 91-degree angle. And an obtuse triangle says we would have one angle that is obtuse, or in other words, greater than 90 degrees. So this 91 degrees here, that's greater than 90, so that is the one obtuse angle. Like I said, you can't have a triangle that has more than one obtuse angle, so we would obviously expect these other two angles to, of course, be acute. However, since we have the one obtuse angle, it is an obtuse triangle. "49 degrees, 49 degrees, and 82 degrees. Is this triangle equilateral?" So remember we said equilateral means that all three sides were the same. And if all three sides were the same, then we would have had to have all three angles the same. And all three of these angles are not the same. So no, this is not an equilateral triangle. Okay, we have a triangle with side lengths 10, 6, and 9. So what kind of triangle is it? So all three sides are a different length. Therefore, it is a scalene triangle. Number 7, is this triangle scalene? So we have a 65-degree angle, a 65-degree angle, and a 50-degree angle. So if two angles are the same, then that means two of the sides are the same. However, scalene means all three sides are different. So for it to be scalene, all three sides being different, then all three angles would also have to be different. And they're not, therefore this is not a scalene triangle. Okay, so sometimes instead of being given dimensions of sides or the measure of angles, you will just see symbols. Okay, so this 1 mark, 2 mark, and then 3 marks tells us that all three sides are a different length. So if all three sides are a different length, then this is a scalene triangle. So in this one, it is telling us that these two sides that have this 1 hash mark through it are equivalent in length. So if two sides are congruent, then that is called isosceles. Okay, so this time we're going to classify it by its sides and angles. Okay, so we know that two sides are the same. So the first thing that should make you think of, since two sides are the same, is isosceles. We see this box here in the corner, which tells us that it's a right triangle. Remember though, whatever these two angles are, they're going to have to be the same because we know that it's isosceles. And I did not spell isosceles right, but that's okay. Squeeze that E in there. So since two sides are the same, then therefore two angles would also have to be the same. So this one, it cannot be acute because we said it was right. So I can eliminate this one and I can eliminate this one. Okay, so our first answer choice is right and equilateral. It is not equilateral because then all three angles would be the same, and they're not. One of them's a 90-degree angle. But down here at the bottom, we can see that it is right, which is correct. It does have the right angle. And it's isosceles because these two sides were congruent. And it is not an equilateral triangle. So the answer choice 4 here, this last answer choice, was your correct answer. Okay, take just a minute and classify this triangle. Okay, we can see that by these marks that we have two congruent sides, which again is isosceles. Okay, let's just go through our answer choices here. Is this an acute triangle? Let's think back. An acute triangle meant that all three angles had to be acute. So are all three of these angles less than 90 degrees? Appears to be to me. Okay, let's look obtuse. Well, let's go back to this first one. They are all acute, but is it a scalene triangle? No, because that would mean all three sides were different. And these two marks tell us that two of them are the same. So we can eliminate that one. And we can eliminate the last one, which also says it's scalene. So we can agree on the isosceles part in both of these answer choices. Now, is it acute or is it obtuse? Obtuse means there's one obtuse angle, and acute triangle means all three angles are acute. So all three of these angles are less than 90 degrees, which makes it an acute and isosceles triangle. Okay, our exit slip today, it says an isosceles triangle has an angle that measures 140 degrees. Which other angles could be in that isosceles triangle? Remember, what does isosceles triangle mean? It means two sides are the same. Okay, so we can choose more than one if we need to, but we've got to come up with two more angles here. And remember, when we add those angles up, we should get 180. So we don't have very much left here to fill in if one of them is 140. That only leaves us 40 degrees. But since it's isosceles, we need both of these to be the same. So we're going to take that 40 that's left and divide it in half and say that they could be 20 and 20. And there's no other way for two angles to be the same, because we could not have another 140 degree angle, because that would be 280, and that's already our limit, over our limit of 180 degrees for a triangle. So answer choice C is the only correct answer for this exit slip. Okay, that completes your assignment for today, or your lesson for today. So you'll complete your assessment on IXL W3.